So for section 2.6, we're going to be solving linear inequalities. The first thing we need to deal with is that we make sure we know how to read each of the inequalities. So this will work as long as the x is written first, and I'll talk about a little bit what happens if the x goes to the other side. But if I read this as, with the x being first, x is less than, okay? So as it points toward the x, x is the lesser of the values, x is less than. If it points away from the x, then x is greater than. This less than with a symbol below it, that line makes it less than or equal to. And then once again, if it's pointing away from the x, it's greater than or equal to. And I'm sure prior to this, you've seen the idea of the mouth, trying to find, that the inequality opens towards the larger of the sides, so x is the lesser, this other number is the greater of the two. That's fine. What might be new is we were going to be graphing these, and you may be used to different points. For instance, when it's not equal to, if it's just less than, we will often use an open dot. Okay? What I'm going to encourage you to start using is these symbols for not equal to, which is a parenthesis. Okay? If you're used to an open dot, and you use that, first of all, the homework won't be that way, but if you use that on the test, I will not freak out about it. I won't mark you wrong, because there's nothing inherently wrong. But for future courses, it's going to be to your benefit to, if it's an open dot or if it's not equal to, use parentheses. If it is equal to, these last two where they have the is equal to, what that does is it changes it so that it is closed. So a closed dot constitutes, instead of a parenthesis, we use this bracket. And the same thing, closed, we would use a bracket. Okay, so a closed or filled in circle or bracket. And then direction we shade, well, if it's less than, number's less than on the number line or to the left. If x is greater, number's greater than that or on the right on the number line, less than to the left, greater than on the right. So if you need to take a second and pause this, but this is something you should have written down, use it as a reference to help you remember. This is not something you want to be making mistakes on and practicing wrong. Okay? So let's start with the first one. Let's just start with reading it. This says x is less than 5. Okay? So I can go over here and just stick a 5 on here, but I would encourage you to start with a reference point. In the middle of the number line would probably be 0. And somewhere to the right, about 5 steps away, would be 5. This says x is less than, not equal to, meaning less than means it's going to either be an open point, if that's what you prefer. Less than means we're going to shade to the left of that. I use less than 5. Like 4, 3, 2. Like negative 10. Negative 10 is less than 5. It's further on the left on the number line. The other option, and this is what I'm going to want to encourage you to do, it's going to be very similar, but instead of using the open dot, you put a bracket facing the way that we're going to shade. Both are technically fine. The one on the right is the one I'm going to be using from this point on. Okay? The next one just adds another little element. It says less than or equal to. Well, what does that equal to? Well, for a lot of you, it's going to mean you're going to include that point, and now you're going to fill it in. And that's fine. Doesn't hurt my feelings. And we're all, either way, going to shade less than, so we're all going to shade to the left. The only thing I would encourage you to start doing is, for the equal to, rather than use a closed dot, put a bracket facing that direction. And that means the same thing. Key here, x is less than or equal to 5. If I put the 5 first, 5 is less than or equal to x is not the same. These do not say the same thing if I switch the 5 and the x. If this confuses you, then put the x first. Put the x there, put the 5. Okay, so this is a separate example. And basically when I switch the order, the mouth stays open towards the x. In this first statement, 5 is less than or equal to x, meaning x is greater. If 5 is less than x, then x is greater. So when I put the x first, x doesn't all of a sudden become less than. X is still greater, so the mouth stays open towards it. Okay? Now I can read this and go straight to the graph. 5 is less than or equal to x. I go to the 5. I put equal to, so I put a bracket. X is greater, so I shade it to the right. If that confuses you, then you need to know how to rewrite it first with the X at the beginning so that you know which direction to shade it. That's probably the most common issue that comes up, and we'll see that as we keep going. But basically 5 is less than or equal to X is the same as X is greater than or equal to 5. If you struggle with going straight from the first one to the answer, which is actually most of you, from my experience, then learn how to switch it. Put the X first, put the 5 at the end, and then the inequality basically flips so that it's still opening towards the X. You will also be graphing fractions. You have your calculator, so worst case scenario, you could do -3 divided by 4. I will give you a hint. This does not go between -3 and -4. It does not. Because 3 divided by 4, 4 doesn't even go into 3 one time, right? If you put that in your calculator, hit enter, that is basically -0.75. Where does that go? Well, we're going to plot that between 0 and -1, closer to the -1. Okay, so right here. Greater than means I'm going to be shading to the right. Not equal to either means I got to fit an open dot in there, or I can add a parenthesis. This says X is greater, shaded to the right, but not equal to, use a parenthesis. Now let's talk about solving. How do I solve an inequality? Good news is, if you know how to solve an equation, and you should if you're working on these notes and on this assignment, we've already been solving equations, we will solve the inequality the same way I solve an equation. The same way. It is the same exact process. You look at this, and if this makes you, fill up with fear and cry at night, tell me, could you solve this? Well, yeah, by now we go, yeah, to undo the adding, we just and get the k is equal to, right? And to keep this balanced, then what we do is we still subtract the 3 on both sides. And what we get is that k is greater than 9 minus 3, 6. I will have some people that have had a teacher that told them just to replace it with an equal sign. You actually can get in trouble with that, so I would encourage you not to replace it with an equal sign. We just treat it like an equal sign. Then how would I graph this? K is greater than 6. I would go 1, 2, 3, 4, 5, 6. Greater than, open dot or parenthesis, opening shaded to the right greater. The only exception to this, the only time where it will be a little different, is if we have to deal with a negative. Not just if I subtract, because we just subtracted and nothing flipped, but if we multiply or divide by a negative, everything flips. Everything flips. And you're like, why? Well, I'll show you. So this is -3 times k. So if I was to solve this like an equation, to undo the multiplication, we would divide both sides by. So what's that going to do? Well, this -15 changes to a positive. 15 divided by 3 is 5. This negative divided by negative makes that k positive. And so when I divide by a negative, the inequality also has to flip. The question is why? Well, one logical way of thinking about it is this. Look, this was a -15, this is a positive 5. This became the opposite. The negative became a positive. This negative became a positive. Everything, every term, when I divide by a negative, becomes opposite of what it was. So does the inequality. The inequality, when it gets divided by a negative, also becomes opposite. The less than becomes greater than. That's a logical way of thinking about it. Easier answer. Why do we flip it? Well, because it's right. 1, 2, 3, 4, 5. Bracket or closed point. If you want to stick a closed point on here and put a bracket later, you can. How does this shade? Well, 5 is greater than or equal to k. Greater than or equal to, in this situation, means I'm going to shade left. Some of you are like, I'm about to shade right. How did you know? Well, if you don't, put the k first, and then the inequality stays pointing at the k. It stays open to the 5. So these say the same thing. So I'm going to shade to the left, and I'm going to use a bracket. So once again, how do I know this is right? Short answer is pick a number past 5. If you had shaded the other direction, like for instance, how about 7? 7 we did not shade, so 7 should not be one of our answers. If I plug in a 7, what is negative 3 times 7? Is negative 15 less than or equal to negative 21? That is not true, is it? Negative 21 is further to the left, therefore negative 15 is not less than, it's actually greater than negative 21. So 7 is not our answer. We did say, I think, that 0, 1, 2, 3, all of those would be answers, so let's just try 1. How about negative 15 less than or equal to negative 3 times 1? Is negative 15 less than or equal to negative 3? Is negative 15 further to the left on the number line than negative 3? Yes, this is true. That means that 1 is one of our solutions. So why do we flip it? Well, whenever we multiply or divide by a negative, everything changes signs. Everything becomes opposite. This becomes positive, this becomes positive. The inequality flips. Why do we flip it? So we get the right answer. Because if I didn't flip it, you would have thought 7 worked, and 7 didn't work. All right, enough of that. Let's keep going. 7 plus 3k. All right, so this we saw before when it was an equation. I've got variables on both sides. I cannot combine across an equal sign, right? That's why I like to draw that line. So what I have to do is I have to move one of them. Would you rather move the 3 or move the 2? Well, those of you who like to keep things positive, we're going to move the 2. That's going to keep k positive. 7 plus 1k is now greater than or equal to negative 5. How do I solve this? Undo the adding by subtracting, so that k is greater than or equal to negative 12. We've graphed this before. And we say, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I probably wouldn't do all that. I would just go look. Here's 0. Negative 12 is somewhere to the left of 0. Greater than means I'm going to be shading to the right. Equal to means I'm going to use a closed point or a bracket facing that direction. Some of you I still haven't converted on the idea of the brackets, but let me show you a good reason why we're going to do this. We're going to write our solution as, I don't know why I put set there, as an interval. Okay, so it's going to be called interval notation. The way we do interval notation is we will have two numbers, either between parentheses or brackets. How do you know? Well, parentheses will be if it's not equal to, and brackets are where it does equal. Okay? And you'll have a minimum and a maximum. Look at this picture that we just drew. X is any number greater than or equal to negative 12. So that means it's negative 12, negative 11, negative 10, 9, 8, all the way to 0, 1, 2, 3, 4. So what if I wanted to write kind of an algebraic way of showing this answer? Well, that negative 12, is it the minimum or the maximum? Is it the lowest point that x can be or the highest point that x can be? Well, it's the furthest to the left that we shaded. So that would be the minimum. So here where I say minimum, I would put negative 12. It said I'm going to either use a parenthesis or a bracket. Well, how do I know? Did it equal 12? Well, yeah, it did. That means I'm going to use a bracket. Make it easier. If I used a bracket in the picture, I use a bracket down here. Because it was equal to up here with a bracket, I use a bracket down here. Comma. I now need the maximum. How high does this go? Well, I know it goes past 0, 1, 2, 3, 4. We shaded this arrow right here. What does that mean? Any number past that, and we're going to go on forever, right? We have a mathematical way of writing that. If it goes on forever, we use the symbol infinity. Right? So what that means is that it's going to shade to the right forever. So our maximum, when we shade the arrow, is going to be an infinity. What symbol do I use on the infinity? Well, can you ever equal infinity? Can you have infinity dollars? See, infinity is an abstract number, goes on forever. So because you can never equal infinite, for the infinities we always use a parenthesis. Let's go back and let's fill these in on the previous ones, but this is kind of our new solution as an interval, or in interval notation. So let's go back here real quick. X is less than 5. Well, is that 5 the min or the max? That 5 is the highest point. So that means that 5 will be at the end. What symbol do I use there? Well, it's an open circle. That means not equal to. Over here, oh, looks like, did I mess up over here? Yes. I just didn't draw it very well. It should be a parenthesis for not equal to, right? Sorry about that. Alright, so it should be a parenthesis for not equal to. So put a parenthesis on the max. I need the minimum. How low do we shade this? Left forever. You're like, oh, infinity. Technically, no. Infinity's over here. This is not infinity because it's not positive. It's -1, -2, -3. So back here, this left arrow means the minimum will be negative infinity. Once again, can you ever equal infinity? No. Same, you cannot equal negative infinity. The infinities will always have a parenthesis. Next one goes left forever. So our minimum is negative infinity, parenthesis, comma, 5 is our max, and this time we use equal to, so we use a bracket. This next one, 5 is our minimum. That's the furthest to the left that we go. So I put a 5, it had a bracket for equal to, put a bracket, comma, the maximum. The minute I shaded this arrow, we shaded forever. The infinities, we never use a bracket. We always will use parentheses because you can never equal infinity. Last but not least, -3/4 was the furthest to the left, so that makes it our minimum. Parenthesis, parenthesis, comma, max. Right forever is infinity. So yes, this will show up in the homework, this will be on the test, but shouldn't be the scariest thing as you go through this. This is something we're going to build on a lot in Math 51. I want to make sure that we've introduced it here. Might as well look at this one. Greater than 6. 6 would be a min or max, right? It's min, comma, max. So 6 would be our minimum with a maximum of infinity. Parenthesis, parenthesis. Okay. And this one, 5 would be our max with a bracket. Left forever would be negative infinity with a parenthesis. Let's keep going. How are we going to solve this? Just like an equation. I've got variables that are on the same side. Simplify. What is -x plus 2x? Do not combine the x and the 7. They're not like terms. On the right side, 3x plus 2 minus 5. Got like terms there. So 3x about minus 3. Now you got two options. I don't like to deal with the negatives. So I'm going to subtract the x. Leaving us with, but what this might do to some of you is it puts x on the right side, and that freaks some of you out. So this is going to be option 1. I'll talk about that in a minute. Let's finish this up though. So then we would add, to deal with the subtracting, 10 less than 2x, divide, and 5 is less than x. We'll get back to that in a minute. What if you don't like having x on the right side? Well, then what you're going to do is subtract this away, move x's onto the left side. 1 minus 3. I'm going to solve it very similarly. To undo the adding, we subtract. Before I keep going, is this going to flip? Some of you are nodding yes. Some of you are thinking yes. Think about this. We said we will flip it whenever we multiply or divide by a negative. Did we do that? Oh yeah, no, we subtracted. That doesn't change everything. This was negative, it stayed negative. This was negative, it stayed. Just subtracting doesn't change everything. So the inequality stays. When does it change? If I multiply or divide by a negative, look what we're going to do next. To undo multiplying, we divide by that negative. So that x, first one becomes x, the second one becomes 5, but the inequality must also flip. Are these answers different? This says 5 is less than x. If 5 is less than x, doesn't it make sense that x is greater than 5? So you got two options. Either you don't like x on the right side, and at the end you go, well, that means the same thing as this, or you keep x on the left side, and you may have to deal with some negatives sometimes. But the answer doesn't change. What does the graph of this look like? Well, we start at 0. Somewhere over here is 5. Greater than means I'm going to shade from there to the right. No equal to means I will use a parenthesis. How would I write that as an interval? 5 would be my min or max. Furthest to the left is our minimum. Our max is to the right forever. That would be infinity. The symbol on that would be both parentheses. We're almost done. If I look at this, how are we going to solve this? Well, same way we did with an equation. Simplify first. I deal with this parenthesis. I cannot do k minus 3, but I can take the 5 and I can distribute it. 5k minus 15 minus 7k. Do not distribute outside the group. Same on this. 4k minus. And do not distribute to the 9. Are we done simplifying? No, we got like terms. What's 5 minus 7? Greater than or equal to 4k. What is negative 12 plus 9? You've got options. Option 1 or option 2. I find more people are successful by keeping things positive, so I'm going to add the 2k. You don't have to do it this way. You could subtract the 4k over and deal with a negative later on. So I have negative 15 greater than or equal to about 6k minus 3. Adding the 3, we have about negative 12 greater than or equal to 6k. Divide by the 6, and we get negative 2 greater than or equal to, k's are getting worse. Sorry about that. K. I know that this is going to be shaded to the left because k is less than. If that doesn't work with you, if you're like, I don't like that, then switch it. Put the k at the beginning, the negative 2 here, and the inequality stays pointing there. What does this look like graphically? Well, 0, negative 1, negative 2. Less than or equal to. Less than means shade to the left. Equal to means closed point or bracket. I like the bracket because it helps me with my interval notation, where my minimum, how far left do we go? My maximum. What symbol do we use on the infinity? Well, you can never equal infinity, so parenthesis. And what symbol do we use on the negative 2? Well, we had a bracket here for the equal to, so we put a bracket here for the equal to. Last but not least, and there are two ways to do this. I'm just going to show you to me what is the easiest way. You can split this. I tend to just look at this as one big equation. It has 3 sides to it, and I'm solving for x. Okay? So x is being multiplied by 3 and subtracted by 5. To undo this, I'm going to need to add 5. But I can't just do that. To keep everything equal, what I do to one side, we do to, not just the other, because there's 3 sides, we do to all 3. Some people will split these. I found that, if you want to look at the book, they'll explain it that way. It's not my favorite way. I find more people make mistakes that way. But if you want to look at it. So 9 less than or equal to 3x less than 15. Last step, since x is being multiplied by 3, we're going to divide everything by that 3, not just to one side, to all the sides. So I get 3 less than or equal to x less than 5. This seems scary. It's actually not as bad. Here's why. This is basically saying, right here, this is saying x is greater than or equal to 3. So here's 0, here's 3. Greater than or equal to means bracket, and we're shading to the right. But we're also saying that x is less than 5. So there's 3, 4, 5. Here's 5. Less than is a parenthesis, but it's shaded to the left. So we really have 2 separate statements here. We are saying it's both greater than 3 and it's less than 5. So what do we keep? We keep the overlap. We keep the middle area. You only keep the area in the middle. That's an AND or a compound statement. How do we do the interval notation? Really easily. Our minimum is 3. Our maximum is 5. On the 3, because it was equal to, we put a bracket. On the 5, since it was not equal to, we put a parenthesis. This should be everything you need for 2.6. You are almost done with this chapter. Keep it up.